To start out this lesson, I want to just ask this question. It says, draw a triangle with side lengths 10 centimeters, 5 centimeters, and 3 centimeters. So I have a ruler set up here. I have 3 different lines. One's 10, one's 5, and one's 3. So I'm going to make 10 the bottom side, and then 5 the left side, and 3 the right side. So let's put this one down here. We'll kind of rotate it. And there's our 10 and our 5, and then we'll just put the 3 so that it connects those two. Let's see. Okay, wait a second. Looks like, let's see, maybe this one's got to be turned a little bit this way. Okay, that's probably better. And then that, whoa, what's going on here? So it looks like they're not going to touch. Even if I swung this one down all the way, I don't think this 3 and 5 would touch. So this is the idea. This is kind of the essence of today. This is called the triangle inequality theorem. And so there's a rule. It says in all triangles, the two smaller sides must add up to more than a third, the largest side. And technically, you see in some books it says any two sides of a triangle have to add up to more than the other side of the triangle. But you can think of it as the two smaller sides must add up to more than the largest side. So, and you can kind of see that here. This one's 10, and 5 and 3 don't add up to 10, so they won't even get close. So even if you had 5 and 5, they just wouldn't touch. And so let me show you here. We'll copy this guy, and we'll try to connect them. And even if we rotate these all the way down, they're never going to touch until they get down here, so it'll just be a straight line again. So as long as these two sides add up to more than the biggest side, then it could be a triangle. So here's 3 examples. This is not a possible triangle because it's 3, 2, and 1. 2 plus 1 is not more than 3. This is not a possible triangle because 3 plus 1 is not more than 8. But this is a possible triangle because 3 plus 6 is 9, which is bigger than 8. Okay. So, now that we know how to look at, are these 3 side lengths a possible triangle, now we can identify, are they right, obtuse, or acute? So right triangles have side lengths. They'll always follow the equation a squared plus b squared equals c squared. That's the Pythagorean theorem. And we'll look at that in a different video next chapter, in chapter 5. So it says, which of the 2 triangles are right triangles? So which one of these, I should have said, which one of the 2 triangles is a right triangle? So I'm just going to sketch this one. We'll say this one's 12, 5, and 13. So we'll go 12, 5, and 13. And I sketched it as a right triangle, but I don't know that it is or is not yet. We'll check that in a second. And this is 12, 16, and 22. And I know that the hypotenuse here is going to be the long one. So let's test it and see if it is a right triangle. So we've got 12 squared plus 5 squared equals 13 squared. And is that true? So we get 144 plus 25. Does that equal 169? And 144 plus 25 is 169. So yes, this is a right triangle. So yes, right triangle. Okay, on the other one, it's 12, 16, and 22, so we'll try the same thing. 12 squared plus 16 squared equals 22 squared. And we'll see if that works. 12 squared is 144. 16 squared is 256. And then 22 squared, let's pull up my trusty calculator here. We get 484. Okay, 144 plus 256, that's 400. Is 400 equal to 484? Nope. So that's not equal, so this is not a right triangle. So the question is next, what kind of triangle is it? Is it acute or obtuse? This angle right down here. It's not 90 degrees because it doesn't follow a squared plus b squared equals c squared. So we saw that a 5, 12, 13 is a right triangle. So what if I made this red line, the hypotenuse, smaller? What would happen to this angle right here? So if I made this smaller, that means this 12 would rotate in, and it would end up connecting with this one now here. So that's our first example. If a squared plus b squared is bigger than c squared, because 5 squared plus 12 squared is bigger than 12 squared, that's pretty obvious. If you're adding something to 12 squared, it's going to be bigger than 12 squared. Then this would be an acute triangle. And so this angle here ends up being acute. Okay, so that's if the hypotenuse, or what would be the hypotenuse, when you do a squared plus b squared, that's going to be bigger than c squared. Okay, and then you can probably guess, if we make this 13 bigger, it's going to swing this 12 out so that it can touch the end of that. So I made it 14, I believe. Yep. So if we go 5 squared plus 12 squared, if that's smaller than 14 squared, let's just double check and make sure that is right. 5 squared plus 12 squared, is that smaller than 14 squared? So we get 25 plus 144. Is that less than 196? Less than 1. That's a less than 196. So we get 169 is less than 196. Yes. So it is true. So that means that if a squared plus b squared is less than c squared, you get an obtuse triangle. Okay. So that is the triangle sum theorem.